So let's get started, ladies and gentlemen. Thanks for joining the session. Today we talk about Tame that beast. That means we will talk about operational efficiency and availability and so forth. And you all hopefully got a little piece of paper with a number. So at the end of the session, my colleague will go around and one of you will be the happy. But you have to probably, we should make it a bit more difficult. So then they should answer some questions or so. Okay. So again, thanks for joining. My name is Stefan Radke. I'm the field CTO for Isilon in EMEA. Isilon is a part of our big data solutions, and I will come to that at the end, so how the portfolio looks like. But first of all, so just a little history. I've been working 17 years for IBM in various technical roles. I have moved to EMC 2011, quite a cultural difference. And have then in 2012 became the CTO for Isilon in EMEA. So this slide, you know all this slide, right, since many years. So this is all about availability, how much it means when you say 3 nines or 5 nines or 99.5%, which would mean 1.8 days outage statistically through the year. And if we talk to customers and ask, over the past 2 or 3 decades, they have developed very much good SLAs for their enterprise data warehouse because it became a core component of their business. And then you ask, what is your uptime SLAs for Hadoop? Most of the time you get the answer, there is none, or we don't know, or something, we are working on it, right? So the good question is, why are they different? We have, in the meantime, we have very good outcomes from Hadoop. Just a couple of examples. You could make that list endless long, right? So there is, so fantastic improvements on Hadoop, just a personal experience. When I first visited a good customer from us, which is Spotify, we were talking about data growth, and I didn't know about the solution. When I went out, I knew about streaming, and I knew they do streaming, but I didn't try myself, ever. So then I was talking about how is the data growth and so forth, because they have our systems. And then they said, well, yeah, we get 20,000 new titles per day. 20,000 new titles per day, which is huge, right? With the biggest and heaviest music format with so forth. And then when I went home, I started using it. And the fantastic thing is not just about you can edit, you can get to every music you can imagine, almost anything. But it starts getting fantastic if you use it for a couple of weeks then, right? So you create your playlists, and then over time you can just ask in different ways, can you recommend new music to me? So and then you hear new music over and over, and the probability that you like it is very, very high. So they came up with a new feature just a couple of weeks ago that says your mix of the week, right? So you get a playlist every Monday, and I can tell you, that's my experience, out of 30 titles there are in, you love 27 because of analytics, right? So, and this is just a not so important example. There are many more examples, right? But then, and obviously that's the core of their business. I'm also Amazon Prime customer, so I could access all the music there as well. But I, love the way how they recommend new music to me. So they are very advanced in analytics with that. By the way, they do not yet analyze the music that you listen. It's just a comparison what other people like to do, right? There's a lot of research on how the music needs to look like with number of beats and so forth, but that's not a solved problem yet. So this is one aspect. So we get more and more importance of Hadoop. Also, I get to customers saying, hey, we want to do enterprise applications on this. I need to stop here because the time. But I can tell you, more and more also enterprise workloads, even backup and archive, go to Hadoop for some reason, right? So then this is one end of the story. The other is that we get more and more enterprise features in Hadoop itself, right? So just some examples here, right? So erasure coding is something that in our enterprise and Scaleout NAS systems, we have that for many years, right? Very stable. It's now, coming to Hadoop as well. Then there's constant work around avoiding this, name node point of failure. And then we have some features around index name node for random access and disaster recovery work. So there is a lot of work around getting to the same level of enterprise functionality and reliability that we have in traditional storage systems for many years, right? So then if we say Hadoop is the modern database and it's getting more and more enterprise features and we have more and more successful outcomes, why are the operations of Hadoop and uptime SLA seems, so much afterthought on most clusters, right? Compared to our traditional IT systems where we talk about high availability, geoscale clusters, and seamless failover and all these kind of things. So, yeah, just a repetition of the same question, right? What about the KPIs? Why don't we have them for Hadoop? And what could we do? And what can go wrong also, right? So there's some interesting articles on what can go wrong, right? So, and the second, for example, is highlighting 8 main reasons why big data projects fail. One of the most important reasons is data silos, right? So there's a lot of data silos, and while you are here these days, you hear about, we're trying to avoid data silos with data lakes and so forth. This is a very important aspect. I will come to that later on. So then some thinking around it. So why is the concept of 99.99 seem so bad for production Hadoop systems? I've said there's a lot of work around it, right? Many customers asking us, what do we do with backups? So far, we didn't do backups. And in the beginning of Hadoop, it sounded probably like a crazy idea to back up data that's existed somewhere else as well, right? But I can tell you, for example, a customer told me, we have the crazy idea of offloading Hadoop HANA data that's 5 years old. Nobody cares about a CRM data that's 5 years old to Hadoop. And we ask, why would you do it? Because it's so much cheaper, right? So it's just, but hey, if we do that, if we offer our users to do, they like the idea. There's tools from SAP that you can offload HANA stuff to Hadoop, and they'd like to do it. But then they say, if we offer that capability to our users, we need to do a backup. How do we do it, right? So. And sometimes, it's good if they ask you before, because many times the companies need to have a catalyst, something that happens before they really start thinking about availability. Right? So why, for example, the question, why wouldn't you like to have 2 fully addressable clusters with, geo-replication? Why wouldn't you something like resilvering when you add capacity? Something like I illustrated here on the right-hand side. So you have a couple of nodes, then you fill it up with capacity, then you add another node because you need capacity. And then automatically the data is rebalanced, right? Oh, that illustration went too fast. So then the stuff is rebalanced. That's something that we have built in our systems. I will return to that later on. Complete fault-tolerant system would be nice. In terms of across data centers, that doesn't exist today. Hadoop is not made for resiliency across more than one data center. And the last point is very important, operational scale that allows 24/7. So, some ideas. I brought with me 3 ideas to think about. This is the first one. The first one is separation of compute and storage, right? So in many cloud solutions that is already done. In our solutions is also a part of the solution. And for many reasons, we do think that's a very good choice. Well, there was always the discussion around data locality and so forth. If you Google, I don't have the time to go through details, but if you Google, there's a lot of articles around why data locality is not really relevant anymore, right? To bring the data to compute. And then what we also see is with Hadoop, so for the couple of 2 decades, the whole industry and all customers worked very much on consolidation, right? Virtualization to be more efficient and shared storage to be more efficient to avoid all these silos that we still have, but it got better, right? Now with Hadoop, we are starting the same thing again. If you look to how production environment look like, they start setting up a Hadoop cluster here, setting up another cluster there, and so forth. That's not something that is very cost effective, nor is it providing any resiliency. Because, yeah, at the beginning, it's almost like we do start trying, but then if they see the benefit, they just want to bring it in production. And that's not good a way to have multiple clusters then. And this is one of the reasons why. If you think about the whole industry and the ecosystem is now forming around data that has some value, and the data sets get bigger and bigger. If you think about, if you asked to the guys from Hortonworks or even all the other guys, they say if you want statistically relevant data, you need to start with 100 terabytes. To move 100 terabytes across a 10 gigabit Ethernet link, even if you have it dedicated, would take 24 hours. And that's just 100 terabytes. Right? So we are really at a point where you can't really move big data sets around anymore, right? So that's why we say that's the last sentence, which is quite important. You need to have something where you can do in-place analytics, right? So instead of copy your data around, just analyze it where it is already. So, and yeah, this is just the illustration of what I just explained. On one hand, we have traditional IT systems, data warehouses and CRM and what have you. And then on the other hand, we have Hadoop clusters or analytic clusters. There's more applications than just Hadoop. And we see, what I said, more and more clusters being set up separately. And then customers come to us and, how do I do the backup? How do I do failover? How do I do resiliency and so forth? How do I do encryption, governance, all these things? So that is what I mentioned already. So it takes a long time to move data. That's not a solution, and therefore that's the idea of the data lake, right? Generally speaking, I mean there are different incarnations and different solutions out there. We have some, as you can imagine, and our solutions. And I will talk about one today, but there is even more. I will mention that we have a whole portfolio, but the idea is pretty much the same. So what we offer with our Isilon system, Isilon is traditionally, since many years, a scale-out NAS system, which supports many protocols like NFS, SMB, FTP, HTTP, and also HDFS, right? That means if you use such a system, I will describe it in a minute, then you can access the data where it sits. You don't need to copy it around, right? If you can access the same data that has landed over NFS, then you can analyze it through NFS or HDFS or what have you, right? And that's a big advantage, of course. And the functionalities that we provide in these kind of systems have been developed for 2 decades almost now, right? So we do encryption, we do, snapshots, we do, parallel replication, all these kind of things. So that's our definition of a data lake, right? So we say it's a consolidation thing and allows for big data accessibility via traditional and next generation access methods. That's what distinguishes us from many other solutions, that it is a single system where the other world is most of the time 2 worlds, like HDFS and POSIX and Windows systems. So for example, in our scale-out system, it has many similarities to a traditional Hadoop DAS cluster in that, first of all, it's built out of purely commodity hardware, right? So there's nothing special in it. There's nodes, right? Like in a Hadoop cluster, it can be 3 to, today, 144 nodes. And it contains internal disk up to 60 of different kinds. And then we have a backend InfiniBand where data exchange is happening, predominantly because we do forward error correction across nodes. So you could think about RAID across all the different nodes rather than disk. So we avoid the 3 copies of the traditional Hadoop. So we are much more efficient. So we have 20, 25% overhead, 30% depending on the protection level that you set. And by the way, you can set it on any directory or file type. It's not required to set it for the whole cluster. And then we have all the front-end protocols, right? Including HDFS that can access the data that sits on the cluster regardless of the protocol you use. And unlike many other systems, we have implemented HDFS natively as a protocol. Not like in many other systems where you need to have client libraries and install all your client libraries on the clients, the libraries. It's native on Isilon, which means on all nodes, which are scale-out, as I said, and all data is distributed across all nodes, what I said, we have a daemon running on all nodes that is translating the HDFS request through internal system calls, and we do store the data on a Unix file system, a scale-out file system. We use FreeBSD, right, for many years now. So it's very reliable and function-rich. And since it is a native implementation of HDFS, you don't need to modify your clients. So this is a request. So you have your Hadoop compute node, and there is a request to a file, and then a name node is running on every node. An active name node. So we don't have this single point of or active standby kind of thing. The name node is running on any node. So every node, any name node knows about everything here. So and then you get the response and it says, okay, the block you're looking for, that is here. And it could be even any other response because all nodes can access all blocks through the backend InfiniBand, right? That's a different to Hadoop. So the difference to HDFS, to be precise, as a file system, while we use it as a protocol. Which also means, in contrast to just a detail, because many people ask about performance, if we do error correction and so forth, that is a bit of a compute overhead. But on the other hand, when you look at Hadoop, that block that you request, 128 megabytes, most of the time is read from a single disk or a single node. In this case, the data is spun across all disks or all nodes in the cluster. Right? So the block size that we do distribute internally is 128K instead of 128 meg. Okay, and then the system just responds, okay, here is your block and just get it. Right? And that means you don't need to change anything on your system. On the other hand, with that architecture, we can, and we do already, but we have, last year, we have delivered 8 exabyte of data, of capacity. We have 150,000 nodes running in the field. And this is the type of data that is coming to Isilon typically. There is almost anything except a relational database. That wouldn't fit very well on a scale-out architecture for latency reasons, right? Anything else that is huge data, that's unstructured data, fits very well on Isilon. Even HBase is a good target for Isilon. So then that means whatever you have, surveillance, analytics on videos, that's a huge topic, right? And you don't need to move that around. Think about that one. That's a good example. So then another example. So this is kind of boring thing so far. If I talk to developers, they say, well, I don't care, right? This is, infrastructure, it's just there. I don't care about that. When I come to this slide, they start to care. And this is because what this shows, if you separate compute and storage, unlike a normal DAS cluster with internal disk, the first advantage is you can scale your capacity and your compute power independently. If you need more compute power, you just add compute. If you just need capacity, you add capacity. The second advantage, and this is even more important to developers and for operations, is that we do, since we have supported that as a protocol, we are backwards compatible. That means that today we support what have you, 2.7, but we also still support 1.5, which means you can point to the same data with different clusters, to the same data with different versions, which means you have a production system running, and then you start developing a new application or set up a new compute cluster, you can point to the very same data, because we do support multiple protocols at the same time, multiple protocol versions. We even support different versions of the distribution. So imagine we have customers coming from Cloudera to Hortonworks. Migration is not a big issue because we don't touch the data. It's storing on a POSIX file system. As long as we do support the actual version of HDFS, and we are working very closely with Hortonworks to be very much on time as fast as possible with new versions of the protocol, if that changed at all. So migrations is not a big issue anymore. So and as mentioned here, so you can access the same data with different protocol versions and different distributions and even different clusters, right? So you don't need to have multiple sets of data. You can just access this with the same amount of, you just need one copy. You can do snapshots, all this kind of thing if you want, and work on that one as well. Well, and then there is one other aspect that is now coming to Hadoop. We started seeing the first version of tiering, which means the following, and that's something we support in Isilon for many years now. So assume you have a cluster of 3 nodes or what have you, and then you can create policies. So one step back. In Isilon, we have different node types. We have very fast nodes with a lot of compute and fast disk, and we have then very dense nodes, a lot of capacity, but in terms of compute per terabyte, that's not so strong. It's mainly for archiving purposes. And then we have some nodes that sit in the middle, right? So, and you would like to store the active data on the fastest nodes and the data that's not active anymore on nodes that are cheaper, but maintain the same path to the data, so not change the logical path to it. And that is happening on Isilon. So we can set up policies that says, hey, all new data that goes to the very fast nodes and all data that is not touched for 30 days, that goes here. And then, you can create another policy that says, hey, move that to even bigger nodes, even cheaper per terabytes, but not so strong in terms of compute power. So And then a new capability that we just released this year, beginning of this year, is a fourth tier or class of storage, which is cloud. That could be an external system, that could be an external Isilon system, that could be an external ECS system, that's EMC's object storage system, or there could be Microsoft Azure or Amazon Web Services. We are even working on getting Google on. So that means that data that has not been touched for some time, you can even migrate it to the cloud automatically by policy. But still, for the user, it looks like it is there, right? So it's really a hybrid solution that can be on-premise or can be even off-premise. Of course, all the data that goes, to the cloud can be encrypted and compressed. And that is seamless, right? So just an illustration for, that's the manager slide. So moving nicely and illustrating policies, if you will. So then I was talking about replication. That's in the works for Hadoop. We are doing that since 15 years. We do it in a parallel manner. It's very fast. You can even saturate multiple 10 gig E-links, if you will. You can throttle it also. So if it's, if you run out of resources in terms of CPU, you can throttle it. But hey, that's done. It's solved, right? So it's not synchronous. It wouldn't really work well in a scale-out manner. If you do synchronous replication, then you add latency, right? So, but you can even configure it to be continuous replication, which means within a minute or something. It depends, of course, whether it's working. It depends on your ingest data rate. Right? Nevertheless, it is snapshot-based. So if you say, I do it every 10 minutes or so, and then you have a failure, you exactly know where you are, right? So that's by definition. And then just a comparison of how that would look like. I will skip this. Typically, we are much more efficient in terms of rack space and power and cooling and stuff, because we don't do the 3 copy blocks for redundancy. We do single copy with erasure coding, which is a 25% overhead or 20%, what have you. Right. So it's a big difference in terms of rack space and so forth that is used for the same amount of capacity and also compute nodes. Because typically, when you use Isilon, you separate compute and storage, you can reduce somehow your compute power, right? So, I mean, if you have it, that's fine. But usually you offload a lot of, because I/O is CPU intensive, right? And if you offload that, from the nodes to Isilon, then you have more compute resources available. Well, one aspect, of course, is when people say, am I going this path or am I going this path? People tend to say, well, if I buy just the pure boxes with internal DAS, that's cheaper, right? Well, if you just look to the cost of acquisition, yes, it's a little bit cheaper. That's true. But then start again, see how you implement all these nice functionalities that we have just gone over. Then it starts really getting important and expensive. And then, make your cost model in a way that really shows you what the costs are in terms of people power and so forth. We can help you with that. We have calculators that are available if you Google it, and we provide that to you. You can put in your own numbers of what your cost for specific things are. We can also help you with that and make it a very detailed thing. And at the end of the exercise, you will see, oh yeah, okay, so I got an idea what else I need to include in that calculation, and then you come up with, yeah, acquisition is just one piece of the puzzle, right? Okay, and then the final idea is, of course, think about build that all yourself or buy a solution that offers some capabilities that you are looking for out of the box. And if you look back, for example, if I compare that to the industry I'm working in with, Scaleout or file systems, why has NetApp and Isilon and others be so successful with file servers instead of using Linux, Unix, NFS servers? They can all do the same from the functional point of view because it's so easy, right? So you get an appliance, you switch it on, you configure some IP addresses, and then here you go. And that's what the industry wants. And I guess we will see this. We will see, and we are working on solutions that do the same. So you get a solution that comes as an appliance is much more easy than you build everything your own. I will show you that in a minute. So our portfolio that has big data systems and extensions and big data solutions, right? So and all these solutions are pre-built, pre-tested, and so would reduce the time that is required to build it all yourself dramatically. So just for an overview. So what I was talking about today was the data lake. So that is our foundation why we think to store, and many customers use it already, store your data on systems that are there that have been developed for many years and just have added Hadoop support with all the nice functionalities. There's even more, there's 2 or 3 solutions that are quite similar, and there's another session on our object solution tomorrow. That's what we call a data lake. And then there are extensions to it. I will give you in a minute an example of one of the extensions. They all are cloud enabled. I've shown you that. So you can even move data off your premise to the cloud, and it's transparent. And it's independent on the cloud vendor. And then we have big data systems that are appliances that come along with ready to go and very easy management. And then even include systems that include the whole application stack on top with Hadoop, with a big choice of applications. I will show you that, and that will be the last slide. So one example of the big data extension that we have is just recently announced the DSS DD5 all-flash array. And that's not only an all-flash array. Oh, I'm sorry. That's quite different and unique in the industry. So Hadoop in real-time analytics, for example, is getting more and more important. And what you always will see and have even in traditional flash systems, even with SSDs and so forth, a lot of latency is coming from that file system layer and the buffer cache and the device driver layer. And we came up with DSS DD5. It's called D5 because it's a 5U chassis that, for any reason, has someone another remote here and want me to finish? I have 6 minutes to go, and I will be on time. So it's not me. So what we did is we created the first industry PCIe switch, if you will, that allows you to put a PCIe adapter, so a special adapter, even in your server, and have an end-to-end PCIe communication. So there is no protocol switch in between, and it's the first system, if I have only one sentence, I would say it's the first system that allows you in-memory speed with a shared storage system, right? And come to the booth. That's my colleague in the red T-shirt. They can explain you and show you that in more detail downstairs. But what we achieve is 100 microseconds latency, and it comes with so it eliminates completely the file system and bifurcation device driver layer from the traditional I/O path. The system has an API. It's a pure object. It has a pure object API. So everything within that you store is an object. You would need to modify so if you want your own application using it, you would need to modify it and use the API for I/O. That has been done for Hadoop already. So we offer SDKs and so forth and APIs, and that has been done for Hadoop already. So and it's been upstreamed, and Hortonworks is working on enabling it also, which means in some time this will be natively available within Hadoop with all major distributions, and enable you to do extremely fast analytics, right? So with a system that has 144 terabytes in 5U rack. So go down to the booth and get more details on this. So another one, and this is now the final slide you wanted me to come to. So I mentioned the data lake solutions, right? So what we see in the industry that many customers are struggling with the many components that are around for different things, right? There is, Hadoop, there is Yarn, there is HBase, there is Hog, there is what have you. And we are about to announce a system in a couple of weeks, I guess. And the internal name is a bit strange. It's FBDL, which is Federated Business Data Lake. It will be launched with a different and probably, hopefully, more smart name. What is behind it is a platform that comes as a appliance that has data manager and ingest manager and analytics manager and all the components that you typically need with a data scientist's working space available and all integrated already. You have the choice of Hadoop distributions that the data scientist would like to use. So today you have a project, and then you say, I need Hortonworks and also Spark and Hog and whatever tools you can point and click, and then this gets provisioned automatically. And then in 5 minutes time, you have your analytics working space available and environment available. It's based today on VMware. There might be other hypervisors going forward. So if you look at this link, you can see a demo, right? It's a flash demo, but you can see how you as a user can point and click, choose what you want, and then you can look at how these things get provisioned for you. And all these you can imagine that all these kind of things, I'm not pretty sure whether we will have all these things that I mentioned here. It's just the vision and the idea are ready for the first release. But if you think about all the different things that you need and integrate and test and so forth with the matrix, and does this version fit to that version, that's a lot of work. And that is all done. Thousands of engineering hours went into bringing this together, have that tested, and have that provisioned automatically. I think that's a pretty cool thing. Okay, so also this is shown downstairs at the booth. And then one final comment, the other solution, so what I explained or what I focused on today was Isilon, which is the Scaleout NAS system, and then we have also a Scaleout object system, which supports many object protocols, even NFS and so forth. That even has Hadoop integrated, right? So, and there is another presentation on this tomorrow, watch out for it, and here I am. Thank you very much for your attention. Do you have questions? No. Okay.
Yeah, do you have some performance comparison between the virtual HDFS solution and the native one in some similar environment?
Yes, we do have. So the question was, do you have performance comparisons, right? Yes, there are performance comparisons. I can provide you the numbers. There has been a validation from ESG or IDC or something like that. And well, the numbers that were mentioned in the paper will show only Isilon is 1.5 times faster than a traditional Hadoop cluster. Honestly, if you look for multiple workloads, we tested a lot of workloads. It's almost the same. There are some workloads that are faster on Isilon. There are some workloads that are faster on a traditional Hadoop cluster, right? But it's not about performance. So you wouldn't buy that for performance. In some cases, we are faster. You wouldn't buy it for operational efficiency. That's the game. Okay. So everything else, we are in the booth. And now we probably pull one of the numbers and have a happy, at least one happy guy today out of this session. So shall I do it?
Go for it.
Okay. That's the reason why I didn't get a paper. So that's number 8. Who is number 8? Wow, in the first row. Congratulations. Yeah. So, okay. So that's for you,
Well,
right?
thank you very much.
Okay, thank you. Okay, thank you very much, guys, and see you downstairs.